This video is going to look at Chapter 6D and 6E on seasonal indices and their application. If we recall from last lesson, when we looked at 6A and the different patterns in time series data, we spoke about seasonality being when the data has peaks and troughs, so a clear up and down sort of pattern that works in a seasonal fashion. So over the space of the year, we see the same trend happening. So this diagram that's on the screen at the moment we looked at in 6A, and if we do have a look at this pattern here, it shows the percentage of hotel rooms that were occupied over each quarter for 3 years. And if we look at this, we can see there's these three troughs here, so 1, 2, 3, and all of these occur in the months of June. So in June each year, we've got a decrease in the occupancy of these rooms. Likewise, if we try and look at the peaks, we've got a peak here, here, and here, and these all peak in December. So that makes sense. Remember, we spoke about people tend to travel in the summer holidays, for example, so we're going to have more occupancy in a summer month compared to a winter month. Now, whilst this is good, for a business trying to analyse how they across the whole year, these peaks and troughs sort of hide an underlying trend, which is that red line that has been drawn on. So the process of seasonal indices is actually to de-seasonalize the data, which removes the effects of the seasons and tries to show us the underlying trend that's taking place so we can then have a better analysis of the situation. In order for us to deseasonalize this data, the first step that we need to do is look at the seasonal index. Now, seasonal indices, that's the plural index, are calculated so that the average is 1. And this means then that the sum of the seasonal indices will add up to the total seasons. So when you create these seasonal indices, or sometimes they'll be given to you, if the seasons are months, remember there's 12 months in a year, so if you add up all of the indices, they will add up then to 12 in total. If the seasons were done quarterly, we have 4 quarters in a year, so the indices would then add up to 4, but they would all have an average of 1 if we then divided that 4 by 4, since there's 4 numbers in the number of quarters we've got. So what these seasonal indices do is they tell us how a particular season compares to the average season. And this means that we can use the seasonal indices to remove the seasonal component, so we can de-seasonalize the data and just look at how the data is overall on an even playing field. Or if we've got data on this even playing field, we can re-seasonalize it to help us make some predictions of what would happen in the future. So businesses might use this then to help them plan for future peaks and troughs and make sure they're staffed accordingly and things like that. So if we look at this situation here, these are an estimation of some seasonal indices for unemployment throughout the space of a year. And so we've got here that for January it's 1.1, February it's 1.2, etc., etc. Now, if we look at all of those indices there, we can check this to see if they all add up to 12 since we've got 12 months. So I've put them all in my calculator here, just added all the numbers together, and you can see then that they add up to 12. So that means that yes, I've averaged out those indices correctly. Now, for us to then actually say what these mean, we've got a question here to interpret the seasonal indices for February and for September. If we look here, when February is at 1.2, what that's meaning then is February has 20% more sales on average. So there's a 20% increase in, say, the unemployment. This was the situation in February. If we look at September here has 0.85. So since 0.585 is sitting under 1, it means that in September there's 85% of the unemployment compared to the average. Or we can even say that in September there's a 15% decrease in the amount of unemployment. So using those figures will then actually get us to deseasonalize the unemployment figures and take away these monthly differences so that our values are more comparable. So when I'm talking about deseasonalizing the data, what we need to do is follow this equation here. So in this equation, it says that our deseasonalized figure is equal to our actual amount divided by that seasonal index. So I've got one problem for us to solve, and it says that the seasonal index for cold drink sales in summer is 1.33. Last summer, a beach kiosk's actual cold drink sales totaled 15,653. What were the deseasonalized sales? So we need to follow that equation, and so the deseasonalized, remember, it's actual divided by the seasonal index. So we're going to take that actual figure of 15,653 and divide that by 1.33. Now, if I type that in my calculator over here and press enter, we can see that we have reduced that number down. And if we round that just to the nearest whole number, 11,769. So we've got $11,769 with the deseasonalized sales. So because summer had a seasonal index of 1.33, that means the summer sales are 33% more than the average. So deseasonalizing it will shrink those summer values down so that they are comparable then to the rest of the values. So it makes sense here that we get a smaller number of 11,769. Now, when we re-seasonalize the data, that's when we're working the other way. So in re-seasonalizing the data, we have got our deseasonalized figure and we want to multiply it by the seasonal index to either increase it or decrease it depending on the situation. So it says here that the seasonal index for cold drink sales in spring is 0.85. Last spring, beach's deseasonalized sales totaled 10,870. What were the actual sales? So to get that actual, we need to take that 10,870 and then multiply it by 0.85. And once again, if I open up my calculator for us, type that in there, to the nearest dollar, we get $9,240. So because this seasonal index was 0.85, remember that means that the sales are 85% of the average sales. So when we've got that spring sale being 1087, to re-seasonalize that, we are making it smaller because it's only 85% of that amount, all right? So that's the first part of this exercise. It looks at getting you to deseasonalize and re-seasonalize the figures. Now, what we can do though is we can deseasonalize things on a larger scale. So what we have here are the quarterly sales figures for Mickey's shop over a 3-year period. And so on the left here, we've got year 1, 2, 3, and then we've got each quarter, so summer, autumn, winter, spring. And so if we read that top row, we're saying in year 1, Mickey's shop sold $920 worth of stuff in summer, $1,085 in autumn, $1,241 in winter, $446 in spring, etc. for year 2 and year 3. And it says here use the seasonal indices below to deseasonalize the sales figures and write your answers correct to the nearest whole number. So for each season here, we've got seasonal indices. So for summer, the seasonal index is 1.03. For autumn, it's 1.15. For winter, it's 1.3. And spring, it's 0.5. And so what these indices are saying to us that in winter, Mickey's sales are 30% more than the average. So deseasonalizing those figures is going to counterbalance that increase that's taking place. But for spring, 0.52, it means her sales in spring are 48% less than the average. So when we deseasonalize this is actually going to bump those spring figures up so that they are then comparable to the other months that are taking place. So to deseasonalize these figures, remember that our deseasonalized amount, oh gosh, I'm writing this gross. To do that, we take our actual number and we divide it then by the seasonal index. So in the table that I've drawn there that's blank, we need to fill in the deseasonalized sales figures for each month, each quarter. So what we need to do is for summer in year one, we need to set up a fraction and we need to take 920, which was the year one summer figure, and divide that then by 1.03. And it wants us to write our answers to the nearest whole number. So to the nearest whole number, that's 893. So I'm going to type this in here, and I might type these, let's just type them in red so you can see that we're adding in these answers as we go along. We need to rinse and repeat that. So if we keep working across year one now, we want to go for autumn and we're going 1,085 divided by 1.15 because that was the seasonal index for autumn. So it's really important that for each figure that you're picking, the quarter that you pick, you need to pick the seasonal index for that quarter. So 1,085 divided by 1.15, that reduces our amount now to 943. I'm just going to, highlight red. Again, winter, 1241 divided by 1.3, and I get 955. And finally, spring, 446 divided by 0.52. Remember I said before, this one's going to increase up for us. So this ends up being 858. Over here, 858. So I've now de-seasonalized the figures for year one. What I would really like you to do here is, so I'd really like you here to pause the video and now rinse and repeat the process for year two and year three. So see if you can work out those de-seasonalized figures for those years. So pause it for me and I'm going to work them out and plot the answers in there.